In this video lecture, we will discuss about momentum. By definition, momentum is product of mass and velocity. And one thing very important about momentum is that it is a vector quantity. As we already know, a vector quantity is a quantity which cannot be completely understood without knowledge of its direction. Same story for momentum as well. Momentum is direction sensitive. In a situation, you have to be very careful. If you see two momentas in opposite direction, one must be positive and other must be, and it is a must, be negative. What is the direction of momentum? As momentum depends on mass and velocity, mass is a scalar quantity, but velocity is a vector quantity. So momentum is in the same direction as velocity is. Direction of momentum depends on direction of motion of an object in a situation. Symbolically, we represent momentum with P, mass M, V stands for velocity in this equation. This is the formula for momentum. Let me write units on the diagram for you, so you know that this must be in kilograms. The velocity must be in meters per second. Hence, momentum will be kilogram meter per second. Momentum is a very common quantity, and it has recently added to IGCSE. Before 2016, it was not part of the syllabus. So we find very few questions in past papers for this topic. Before we start doing questions and go to the exam style questions and examples, let me give you some examples. Over here, you can see a concrete truck. That is a massive thing. We all know, we all must have seen one. Or any truck or bus you can think of, a large vehicle. And this is a departmental store trolley, an empty one, nothing is inside. So we know that this truck and this trolley, we are familiar with these two things. And let's consider you're looking at them and they both are moving with the same speed. Now, just consider there is a wall right in front of them and they both go and hit the wall. Which one you think will damage the wall most and why? Although they are moving with the same speed, but we know this truck will damage the wall far more than this trolley. And the reason is not the velocity in this case, it is the mass. And over here, I have two examples. This is a bullet, an ordinary bullet. If we toss it in the air, it is very easy to catch. But once we fire it with a gun, the only difference is this one is far faster than this one. So speed in this case, or the velocity, is making all the difference. Mass is same in this case, but the velocity is different. Velocity is same in this case, but mass is different. So separately, they both influence what an object can do because of its motion. And together, the knowledge of mass and velocity, if we combine them, that becomes momentum. The unit of momentum, as we have already discussed, it is kg meter per second. It is also Newton second, and later we will know in this lesson why it is called Newton second as well. Here is another quantity that is very related to momentum. This is called change in momentum. Apparently it looks like momentum, but change of momentum is discussed as a separate quantity, and it has a name. It is called impulse. Impulse simply means how much momentum has changed because of some force acting on the object. Here's an example. If you can see, this is a mass of m kg which is exerted by a force F that makes the object go accelerate in this straight line, and its velocity from u meter per second, it becomes v meter per second. The time it takes to happen, the whole scene, it takes, for example, t seconds. If somebody asks you what is the initial momentum of this ball, initial momentum, so as momentum is mass into velocity, what do you think, what will be the initial momentum? Initial momentum will be mass into velocity, but velocity will be initial velocity. Final momentum will be mass into final velocity. So change in momentum is change in momentum equals mass into final velocity minus mass into initial velocity. This change in momentum is also known as, this thing is also called impulse. Impulse is change in momentum. And one important thing is that change in momentum, which is mv minus mu, is also equals to net force multiplied by time. This is a very important formula. Sometimes he asks you to find momentum and the data given forces you to use this equation, this form, mv minus mu. Sometimes data is given over there and the relation that you need is that the impulse equals to force multiplied by time. So I will write both of the formulas separately over here. Impulse is final momentum minus initial momentum, or impulse equals force into time. But remember, in this case, force is net force. It is net force acting. So if the unit of force is Newton and unit of time is seconds, impulse will be Newton second, which is simply change in momentum. So Newton second is also the unit of momentum, and this is why in the beginning of the lesson I told you that later we will discuss, and here is the point. Newton second is a unit for momentum. Here is a question for momentum. You can see a mass that is represented by a circle over here. A mass that the value of that mass is 200 kgs. It is exerted by a backward force of 100 Newton and a forward force of 500 Newtons. Initially it is moving with a velocity of 10 meters per second towards right. Hence this force will produce a net force to the right as well, and that we can simply understand that the object will accelerate. This force thing and this situation keeps on happening for 50 seconds. And for that 50 seconds, the question demands us to find out how much net force is acting on the object. What is its acceleration? The final velocity, initial and final momentas, and change in momentum. Now I suggest, if you are a confident student and you know these things, you should pause this video over here and see how to solve this question by yourself. You should try to solve this question by yourself, and then resume the video and see how did I do it, and then you can check your answers. Here is list of some formulas that you need to solve this question. Net force is simple, that you have to find how much force is actually causing the object to accelerate. That will be 500 plus negative 100. As force is a vector quantity, again, let's spend a minute on this to understand. Every vector quantity, if you see a vector quantity in two opposite directions in the same situation, you have to believe that one of them is positive and other is negative. I am considering this one as positive and this one as negative. So total force is simply we add forces, but we add with their direction. It will be 500 plus minus 100, and eventually the net force will be 400 newtons acting towards right. And these are the formulas. If you need help with the formulas and you want to do the questions by yourself, still you haven't done it, I will recommend that you pause the video now and solve it by yourself looking at the formulas. Otherwise, I'm about to solve them now. For the first part, answer should be, is the solution for the first one, 500 minus 100 equals 400 Newton. This is the net force acting. And as we know that F equals to ma, that is a formula that connects net force with mass and acceleration. We can use that to find acceleration, which will be net force of 400 divided by mass of 200, and answer will be 2.0 meter per second square. If we have acceleration and we need velocity, we all know acceleration equals to final velocity minus initial velocity divided by time. In that whole equation, the only missing part is final velocity, and that is what we have to find out in third part. So acceleration, which is 2, equals final velocity that we are looking for minus initial velocity, that is 10, divided by time, which is, the time is 50 seconds. So when I solve it, this 50 goes from here to there on the other side of the equal sign, and as it is dividing over here, when it goes over there it multiplies, and then this minus 10, when it goes over there it becomes plus 10. 50 multiplied by 2 is 100, plus 10 should be 110. So final velocity will be 110 newtons. Now, final momentum and initial momentum. It is very simple. Actually, it is mass multiplied by initial velocity that should give you initial momentum, and mass multiplied by final velocity should give you the final momentum. We know initial velocity is 10, mass is 200. So initial momentum should be initial momentum should be mass, which is 200, multiplied by 10, and that should come to 2000 kg meter per second. For final momentum, again the mass will be same, 200 multiplied by 110, and it will produce 22,000 kg meter per second. Kg meter per second, that's more like it. And in the final part, the examiner says we have to find the change in momentum. So how will we find change in momentum? Is actually final momentum minus initial momentum. So it is 22,000 minus 2000, and the answer should be 20,000 kg meter per second, or you can also say it is Newton second.